And then there's the universe, the death of the Sun, the collision of the Milky Way galaxy with the Andromeda Galaxy, and possibly the Big Rip. The telescope's camera has subtle changes in the way it captures images over time. NASA has just issued a startling warning. The Andromeda Galaxy is on a direct collision course with the Milky Way. For years, astronomers have predicted this event, but new research from NASA suggests the outcome might be more certain than previously thought. While the collision of these two massive galaxies seems inevitable, what does this mean for our galaxy? How will this cosmic collision unfold? Andromeda, also known as Messier 31, is about 2.5 million light-years away and moving towards the Milky Way at 68 kilometers per second. Earlier studies indicated a head-on collision, leading to the formation of an elliptical galaxy dubbed Milkomeda. Such galactic mergers were common between 6 billion and 10 billion years ago and have significantly influenced the structure of our universe. Led by Tsala from the University of Helsinki, a new study highlights that uncertainties in measuring the galaxy's movements and masses, along with the gravitational effects of nearby smaller galaxies, could potentially alter the predicted outcome. The research used data from the Gaia and Hubble space telescopes to explore different scenarios in our local group of galaxies. The Triangulum Galaxy, another spiral galaxy located approximately 2.73 million light-years away in the constellation Triangulum, was added to the collision simulation created by NASA experts. This increased the likelihood of a merger, whereas considering the Large Magellanic Cloud's orbit made a collision less likely within 10 billion years. If no merger occurs, the galaxies could simply pass each other, potentially disrupting and ejecting some of their outer regions into space. Despite the 50% chance of collision, any direct impact on our solar system would be minimal. Defying ideas that we're the only ones in the whole universe and that intelligent life is so rare it only happens under perfect circumstances, future data from the Gaia mission may help clarify which nearby galaxies hold the strongest influence on this potential merger. If the Milky Way and Andromeda do collide, our solar system might be moved to one of the new galaxy's outer arms. This process would predominantly be orderly due to the ample space between stars and would create stunning trails of stars and new bursts of star formation. After 10 billion years, as the universe continues to expand, Milkomeda will dominate our visible universe, with distant galaxies receding beyond sight. If the universe is expanding at such an alarming rate, as observed through the increasing distances between most galaxies, why are some galaxies, such as these two, moving closer to each other instead of drifting further apart? To explain this in simpler terms, the expansion of space is a fascinating phenomenon that dictates the movements of galaxies across the universe. This cosmic expansion influences galaxies differently based on their distances and gravitational interactions. While Andromeda and the Milky Way are moving towards each other, defying the general expansion trend, this is due to the overpowering force of gravity at play between them, a force strong enough to counteract the expansion of space on their scale. According to the laws of physics, if you could build a spacecraft that travels very close to the speed of light, you could shrink the distance to the Andromeda Galaxy and, therefore, the time it takes to get there by an arbitrary amount. In contrast, some regions, like voids, experience faster expansion than dense galaxy clusters. Dark energy plays a crucial role, subtly accelerating the universe's expansion and impacting vast scales beyond gravitationally bound systems. This cosmic tug-of-war between gravity and expansion raises intriguing discussions about the universe's structural dynamics and future, especially concerning local groups like ours that may eventually merge under gravitational pull. But what if this cosmic collision happened tomorrow? Would all the stars and planets crash into each other? Could our solar system withstand such a massive impact? What mesmerizing spectacle would unfold from Earth? If the universe is so big, wouldn't every single potential situation happen an infinite number of times? It's infinite, or at least, we don't know if it's infinite. In our observable universe, there are at least 100 billion galaxies. Large galaxies frequently collide. In fact, they merge roughly once every 9 billion years, while smaller ones collide even more often. But wait, what about dark energy, the force that supposedly pushes the universe apart? For neighboring galaxies, gravity takes the lead. Andromeda and the Milky Way are no exception. Both harbor central supermassive black holes destined to unify their star systems. Imagine a scenario where this monumental collision occurs tomorrow. Andromeda is still quite distant, spanning 2.5 million light-years, a vast gap to close in just one day. But let's assume the supermassive black hole at the Milky Way's center immensely increased its gravitational pull on Andromeda's black hole, causing the Big Crunch 4 billion years ahead of schedule. What would ensue? Firstly, the Milky Way and Andromeda, as spiral galaxies, would become entirely different, a unified elliptical galaxy. We could dub this new formation Milkomeda or Milkdromeda. As Andromeda encroaches on the Milky Way, our Sun and Solar System might be pushed to the fringes of this newly formed galaxy, relocating 26,000 light-years farther away. A best-case scenario would place us on the outskirts, but in the worst case, we could end up in a galactic hinterland, 160,000 light-years distant from Milkomeda's center. What about the stars in both galaxies? While the Milky Way boasts around 250 billion stars and Andromeda exceeds 1 trillion, they are all separated by vast expanses of empty space, making star collisions improbable. Instead, they would scatter into new orbits. Oh, and let's not forget our uninvited guest, the third galaxy, the Triangulum Galaxy, M33, a smaller companion to Andromeda. It could add to this cosmic mashup. From Earth's view, this event would be nothing short of spectacular, with the dazzling core of the newly shaped supergalaxy lighting up the night sky. Eventually, the supermassive black holes at the center of these galaxies would draw near and merge. This convergence would create a bright quasar at the galaxy's core, an astonishing display for any observer on Earth. Sadly, our planet won't endure to witness it. By the time Andromeda and the Milky Way collide, the Sun will have transformed into a red giant, consuming the Earth. In conclusion, the cosmic dance between the Milky Way and Andromeda highlights the intricate balance of forces within our universe, where gravity and cosmic expansion play out on a grand scale. While the possibility of their eventual collision captivates our imaginations with scenarios of unprecedented celestial beauty and transformation, it's a reminder of the dynamic nature of our cosmic neighborhood. Whether they merge to form Milkomeda or continue their paths without significant interaction, this event will unfold long after Earth's habitable days have ended. However, as we contemplate the vastness and complexity of the universe, it becomes apparent that the interactions between galaxies and other cosmic entities are not simply a matter of theoretical interest. They play a central role in shaping the cosmos. Galaxies themselves, like the Milky Way and Andromeda, are dynamic and evolving systems. Their evolution is driven by complex gravitational interactions that can have far-reaching consequences. These galaxies are not isolated. They are part of a larger cosmic web, interconnected by gravity, dark matter, and other forces that influence their paths through the universe. This network is constantly shifting as galaxies merge, collide, and interact in a cosmic ballet that has been unfolding for billions of years. Over the course of time, galaxies evolve through mergers and accretions, which are processes of gathering smaller galaxies and other objects into a larger structure. These galactic mergers are thought to play a critical role in the formation of the large-scale structures we see today, from the supermassive black holes at their centers to the sprawling stellar populations and nebulae that make up the fabric of galaxies. The merger between Andromeda and the Milky Way, as predicted by current models, will lead to the formation of a new galaxy, potentially resulting in a structure much larger and more elliptical than either of its progenitors. This process will fundamentally reshape both galaxies, altering their star formation processes, the behavior of their black holes, and the distribution of matter across the galactic plane. Yet this transformation will not occur overnight. Even though the Andromeda Galaxy is moving towards the Milky Way at a considerable speed of 68 kilometers per second, the collision will not happen for another 4 billion years. During this time, both galaxies will continue to evolve, each potentially undergoing smaller-scale interactions and star formation events. The stars in these galaxies are spaced so far apart that direct collisions between individual stars are unlikely. Instead, what will occur is a gradual reshaping of their galactic structure, a process that will take hundreds of millions of years. The Milky Way and Andromeda's supermassive black holes are another fascinating aspect of their eventual merger. These black holes, residing at the centers of their respective galaxies, are among the most massive objects in the universe, with masses ranging from millions to billions of times the mass of the Sun. When the galaxies collide, these black holes will move closer to one another and eventually merge. The resulting event would release an enormous amount of energy in the form of gravitational waves, detectable by future observatories. This process, which occurs when two black holes spiral towards each other and merge, would be a spectacular cosmic event. As the galaxies approach each other, their gravitational forces will begin to distort their shapes, stretching the galaxies into elongated forms. During this period, stars and gas clouds will interact in complex ways, leading to the formation of new stars and possibly the ejection of large amounts of gas and dust from the galactic systems. These interactions will cause bursts of star formation as the gas clouds are compressed by the gravitational forces of the colliding galaxies. Eventually, after the merger, a new, larger galaxy will emerge, likely taking on an elliptical shape due to the mixing of the stars from both galaxies. However, despite the dramatic changes happening on a galactic scale, the impact on our solar system is likely to be minimal in the short term. While our solar system might be displaced, as discussed earlier, it is unlikely to experience any catastrophic events. The vast distances between stars mean that collisions between individual stars are extremely rare. Our Sun's fate will be determined by its own life cycle rather than the galactic merger. Over time, as the Sun exhausts its nuclear fuel, it will expand into a red giant, eventually consuming the inner planets, including Earth. But this will happen long before the Andromeda Milky Way merger reaches its final stages. As we move forward in time, the expanding universe will continue to shape the cosmos in ways that are still not fully understood. One of the biggest mysteries is the role of dark energy, a force causing the acceleration of the universe's expansion. While dark energy is still not fully understood, it is believed to make up around 68% of the total energy content of the universe. Its effects can be seen in the increasing distance between galaxies and the growing acceleration of that expansion. Despite this, gravitational forces, like those between the Milky Way and Andromeda, can still overcome the effects of dark energy, leading to galaxy mergers that defy the general trend of cosmic expansion. The question of whether the universe is infinite continues to intrigue scientists. Current models suggest that the observable universe is finite, with a limit to how far we can see due to the speed of light and the age of the universe. However, it is possible that the universe extends beyond what we can observe, potentially stretching out infinitely in all directions. If this is the case, then every possible cosmic event, from galaxy collisions to the formation of new stars, could occur in